Hello everyone, I am Teeraj Singh Binjwa from Team Core Clinical. I have submitted my project under the category AI for Healthcare and Life Science for AI for Bharat competition. This is a demo of the project working. I'll start by talking about brief about the project. So this idea about an AI-powered eligibility engine has come with the problem that we noticed that there is a gap between patients and life-saving clinical trials. Most of the systems offer overwhelming keyword searching where you need to type a word like diabetes and you will get 50,000 unorganized results, which has a lot of medical jargon and it's difficult to figure out which are the right ones for the given patient. Our solution is going to be a hybrid filtration system that understands medical context, instantly narrowing down thousands of trials to top 3 to 5 relevant searches. But that's not all. The main thing that we offers here are explainable results. How our entire system works? It starts by first smart profiling. It captures patients' demographic and medical history and has an hybrid intelligence. First, we use SQL hard filtering to filter out the trials based on some key criteria like age, gender, or location. Having a fuzzy matching around location for a little bit of leniency for testing, specifically for a prototype. And then we have a generative AI for soft matching to interpret the complex eligibility criteria. And the AI doesn't come back saying the trial is good or bad. It comes back saying that why is the trial good or bad. It gives you a detailed explanation around it for the criteria that it used to pick a trial, which a medical person can validate before using that particular trial for reference. Now I'll show you a demo. For the demo, we'll go to the front end hosted using CloudFront. For the prototype, we have ingested roughly 6,000 data points, 6,000 trials, and that's a small sample. So we have got two test patients with us. For the first patient, we have the condition asthma selected. Here you have an option to select other also, a disease outside the given list. Then we can pass the age that is 35, a female. Then we specify the location. So for this particular test, we are taking Chicago. This can be taken anywhere else also once we have ingest all the data available on the open source API. After that, we'll add the condition and if we just bring it down somewhere in 70 miles. Then once we click on the find matching trials, we'll search for the system and come back to the trial. Now here if you see in the trial, there are key pointers to note. It's not just giving us which trial matched. It first gives us the key eligibility criteria for the trial. It also gives its prediction on top of that, that what all matched and what didn't match, that also it gives, and overall confidence score that the model had. So this gives us a more in detail understanding for the medical person to decide whether to use this trial or not. Using another example, let's take for diabetes. There is a 55-year-old male, and the person is in New York. For another distance has been set based on the given data. In future edition, we can add kilometer too. And here we'll add the condition medical history. So after that, if I do find matching trials, system will look into that. And here you see, given the number of trials that we have, it doesn't have a lot of data around diabetes. So the trials that it has, it doesn't have a lot of confidence. It's 30% only. So it's given three trials having 30, 25%, and 10%, along with the detail for each one of them that why it has scored them, and even it had some penalty applied to the scores, right, for the parameters that were not included. So, thank you.